Are you ready to set sail towards new horizons in the cyber world? Imagine holding a key that unlocks the mysteries of cybersecurity, and that key is Linux. Linux is an operating system like Windows. One of the biggest differences between the two is that Linux is open source, while Windows is closed source and commercial software. Because you can't access Windows source code, there isn't full transparency about how the system operates. Why Linux? Because Linux offers an excellent platform for cybersecurity and ethical hacking. Specialized security distributions like Kali Linux and Parrot OS come with hundreds of pre-installed tools. To learn Linux, we will follow these topics in order: command line, basic commands, file hierarchy, file management, permissions, user management, usage of cybersecurity tools, final remarks. Let's get started. Linux command line, considered the heart of Linux. You know that black screen? Yes, that one. Many people are afraid of the command line, but actually, it is our best friend. What is the command line? Simply put, it's an interface where we communicate with our computer by typing text. Why is it important? Because through the command line, we can have more control over the system and do our tasks much faster. So how do we use it? To explain this concept, think of command line instructions as having a structure like command plus parameter plus value. For example, in ls-l/home/ronin, ls is the command that lists files, -l is the parameter requesting a detailed listing, and /home/ronin is the value specifying which directory to list. Of course, you can get output by simply typing ls, since default values are defined. Remember, using parameters or values isn't always mandatory. Learning how each command is used helps you understand when and how to use them effectively. We can start by opening the application called the terminal. The icon of this application is located at the top of the screen in Kali Linux. A black screen with a blinking cursor will appear. This is where the magic begins. Let our first command be ls. This command lists the files in the directory you're in. Try it out. Type ls in the terminal and press enter. The files are displayed. You can also list the contents of other directories. For example, if you want to see what's inside the music folder that you currently see on the screen, you can type ls music in the terminal to list its contents. This way, you can see what's inside without entering the folder. Another basic command is cd. With this command, you can navigate between directories. For example, by typing cd documents, you can go to the documents folder. So how do we go up one directory? With the command cd ... Lastly, let's talk about the man command. This command shows the manual pages for other commands. For instance, if you type man ls, you can learn all the details of the ls command. You can immediately use what you've learned from this manual. For example, I learned about the -l and -a options. Now, by typing ls-l-a in the terminal, you can display detailed information and show hidden files together. For convenience, you can also write it as ls-la. As you can see, the command line isn't that scary, is it? With a bit of practice, you too can become a command line master. Now that we've examined the command line, we can look at some basic commands. These commands help us perform daily tasks in Linux and obtain information about the system. First, let's talk about the pwd command. D stands for Print Working Directory and shows the directory you're currently in. When you type pwd into the terminal and press enter, you can see where you are. Next is the whoami command. This command shows which user you are logged in as. When you type whoami, your username will be displayed on the screen. Now, what we will examine is the date command. date command displays the system's date and time information. By typing date and pressing enter, you can find out the current date and time. Next up, let's explore the uname command. The uname command provides system information. By typing uname-a, you can see the kernel version, system name, and other details. Moving forward, our focus shifts to the ps command. The ps command lists the processes running on the system. Typing ps shows the processes in your current session, and ps-e lists all processes. The following command we'll discuss is echo. The echo command is used to display text on the screen. For example, by typing echo hello world, you can display hello world in the terminal. With these basic commands, you can communicate more effectively with the system and simplify your daily tasks. While you can perform these tasks through the graphical user interface, you'll find these commands truly useful when you only have a terminal session. You'll especially realize how beneficial these commands can be in topics like Linux security and hardening that we'll discuss in future videos. If you'd like us to cover these topics in more detail, please let us know in the comments. We'd be happy to create new content based on your feedback. What about files and folders? Now let's understand how files and folders are organized. We can think of it like a tree. At the top, there is a root, and from this root, the branches extend downwards. Like a tree, the Linux file system is divided into branches, and each branch has its own task. I will explain what these folders are used for in a single sentence. It might be a bit hard to learn them like this because explaining this way can be boring. You'll learn them as you use them in your daily life. Still, let's briefly mention what each folder does so you can become familiar. This is our topmost root directory. All files and folders start from here. Bin. It is the directory where basic system commands used daily are located. Boot. Stores the boot files needed to start our system. etc hold system configuration files. Settings are found here. Home. The directory where users store their personal files. There is a separate folder for each user. Lib contains shared libraries needed for the system and applications. Opt, the directory where extra software and third-party programs are installed. Sbin contains administrative commands used by system administrators. TMP, the directory where temporary files are stored. Files used temporarily by programs are kept here. USR, a comprehensive directory containing user applications and files. var, the directory where variable data is stored. Log files and emails, which are constantly updated, are found here. dev, the directory where hardware devices are represented. All devices in the system are shown here as files. proc contains virtual files like running processes and system information. Each directory contributes to the orderly and efficient operation of the system. Thanks to this structure, we can easily find our files and better understand our system. To better understand how the file system is organized, let's explore the /home directory. Let's open the terminal and navigate to this directory. Let's see which users are on the system. We can use the ls command to find out. On my system, it looks like there are users named Kali and Ronin. Now let's go into the Ronin users directory and see what's there. Here, we can use the ls command again to list the files, but if you want to see the directory structure recursively, we can use the tree command. As you can see, we've navigated through the hierarchical file system and observed how the files are organized more clearly. The tree command displays subdirectories and files in a tree structure, making it easier to understand the layout of the file system. Through this simple exploration, we've practically seen how the Linux file hierarchy works and how files are organized. How do we manage files and folders? Having previously explored the command line and file hierarchy, let's now look at how to work with files and directories. As users, we need to be able to create files and folders, read their contents, and perform operations like copying, moving, and deleting. Let's examine how we can do these from the terminal. We've already seen some commands before. Now let's dive into the details and learn new commands. To create a new directory, we use the mkdir command. For example, by typing mkdir projects, we can create a directory named projects. To create a new file, the touch command is useful. By typing touchnotes.txt, we can create an empty file called notes.txt. We can view the contents of files using the cat command. Typing catnotes.txt displays the content of the file in the terminal. If we want to edit the content of the file, we can use a simple text editor called Nano. Exiting the Nano editor might be a bit tricky for beginners. Don't worry, it's much easier than exiting Vim. Quick search will help you figure it out. To copy files, we use the cp command. For example, the command currently on the screen copies the notes.txt file to backup.txt. To move or rename files, we use the mv command. Typing mv notes.txt document / moves the notes.txt file into the documents directory. If we want to rename the file, we can use the command currently on the screen. To delete files, we use the rm command. Typing rm backup txt deletes the backup.txt file. We can delete directories using the rmdir or rm-r commands. For example, to delete an empty directory, use rmdir old projects, and to delete a directory that contains files, use rm-r old projects. Be careful, these actions cannot be undone. We can quickly find the location of files and directories using the find command. For example, find.name notes.txt searches for the notes.txt file in the current directory and its subdirectories. Now let's look at file and directory permissions and how to manage them. In Linux, every file and directory has its own ownership and permission information. These permissions determine who can read, write, or execute the files, and they are really important for system security. To view the permissions of a file, we use the lsl command. When you run this command, you will see some letters and dashes next to the files on the screen. These represent the permissions of the file. These letters and symbols are: the letter R represents the read permission, the letter W represents the write permission, the letter X represents the execute permission. If there is a dash instead of a letter, it means that permission is not granted. The D at the beginning indicates that the file is a directory. It looks a bit complicated, doesn't it? Let's explain it in more detail so it becomes simpler. Permissions are divided into three groups: the user who created or owns the file, the group users that the file belongs to, all other users on the system. Each group has read, write, and execute permission set. For example, if you see that the permissions of a file are like on the screen, this means the file owner has read and write permissions. The group has only read permission. Others have only read permission. Of course, in general, we don't see it segmented like on the screen, but we see it combined or even prefixed with a dash, D, or L character. So what do these mean? Dash indicates that it's a regular file. D indicates that it's a directory. L indicates that it's a symbolic link. For example, when we see permissions like on the screen, the first character D signifies that it's a directory. The remaining characters show the permissions. The owner has read and write permissions. The group members have only read permission. Others also have only read permission. That's enough theory. Now let's apply this on Kali. Let's check the permissions of test.txt. To change the permissions of a file, link, or directory, we use the chmod command. With this command, we can add, remove, or change permissions. To add execute permission for all users, we can use the command on the screen. This command adds execute permission for the file owner, group, and others. Instead of X, we could also use W for write. Using W grants write permissions, while using R grants read permissions to all users. We use the plus symbol to grant permissions and the dash symbol to revoke them. For example, as shown on the screen, it removes the execute permission from all users. If we want to grant permissions only to specific user groups, we need to use the letters U for user, meaning the file owner, G for group, meaning the group associated with the file, and O for others, meaning all other users. To give execute permission only to the file owner, use the command on the screen. To remove write permission from the group, use the command on the screen. To set permissions more precisely, we use the numeric method. Each type of permission has a numeric value. Read is 4, write is 2, execute is 1. We determine permissions by adding these values for each user group. Let's illustrate the numerical permissions with a graphic. File owner, represented by U, has a total value of 7. This comes from read equals 4, write equals 2, and execute equals 1. Group, represented by G, has a total value of 5, from read equals 4 and execute equals 1. Others, represented by O, have a total value of 4, which comes from read equals 4. Using these values, we set the permissions with the command. This method lets you assign permissions precisely. Most people, myself included, prefer using numbers to set specific permissions, especially when they don't want to give full access to everyone. So, take some time to get used to this numbering system.
How do we manage users?
Next up is user and group management. As an ethical hacker learning Linux, you might need to create new users, set up groups, and manage permissions. Let's see how we can do these tasks from the terminal. Before we start the topic, there's an important command we need to mention: sudo. The sudo command allows us to have administrator privileges to perform certain operations. Especially when making system-level changes like user and group management, we will need to use sudo. For example, when we want to create a new user on the system, we type sudo user_add_bob into the terminal. This command requires administrative privileges, and we gain this privilege by using sudo. Now we can proceed with the topic. To create a new user, we use the user_add command. For example, by typing sudo user_add_bob, you can create a new user named Bob. To assign a password to the user, we use the passwd command. By typing sudo passwd bob into the terminal, you can set a password for the Bob user. If you want to remove a user from the system, you can use the userdel command. For example, by entering sudo userdel bob, you can delete the Bob user. If you also want to delete the user's home directory and personal files, you can add the -r option to the command. To create a new group, we use the group add command. For example, by typing sudo group add developers, you can create a new group named developers. To add a user to an existing group, we use the user mod command. For example, by typing sudo user mod -ag developers bob, you can add the Bob user to the developers group. To see which groups a user belongs to, you can use the groups command. By typing groups Ronin into the terminal, you can list the groups that the Ronin user is a member of. To grant sudo privileges to a user, we need to add them to the sudo group. We do this by using the command sudo usermod -ag sudo bob. After reboot, the Bob user can perform actions requiring administrative privileges using the sudo command. Now that you know how to manage users and groups, you can configure your system according to your needs. By exploring further and practicing, you'll become more proficient in Linux administration. I explained Linux to you in a way that can be covered within the duration of this video. Now you might be asking me,
what about cybersecurity tools?
Nice question. Linux offers many powerful tools used in the field of cybersecurity. In this section, we will examine commonly used tools like Nmap and Hashcat. Before using these tools, it's important to research how they work and what options they have. We can partially do this research using the --help.
What is Nmap and what is it used for?
Nmap, or Network Mapper, is a powerful tool used for network discovery and security auditing. Let's start by examining the options and usage of Nmap. To do this, we can use the command nmap-help. This command displays the basic usage options and parameters of Nmap. As you can see, there are many parameters available. We will prepare a separate video for Nmap in the future. But for now, using the -T4 option will suffice. The -T4 option sets the timing template to speed up the scan. Now, let's scan the scanme.nmap.org subdomain using the -T4 option with Nmap. It might take some time for the results to come in, so I'll skip the waiting part. And there we go. The results are in, and we can see that some ports are open. After identifying open ports with Nmap, the next step is to analyze the services running on these ports. This can help us understand the potential vulnerabilities and plan further actions, such as vulnerability assessments or penetration testing.
What about Hashcat?
Hashcat is a fast and flexible tool used for password cracking and testing password security. To see the available options, let's use --help. As you can see, Hashcat also offers a lot of configuration options. Don't worry, we'll create a detailed video about this tool in the future. For now, let's explain the command we'll use. M0 specifies the hash type. 0 stands for MD5 in Hashcat. MD5 is a widely used cryptographic hash function that generates a 128-bit hash value. A 0 sets the attack mode. 0 represents a dictionary attack, which systematically tries passwords from a predefined list. Hash.txt is the file containing the hash you want to crack. Last one is the word list file path that Hashcat will use to try and match the hashes. This command attempts to crack MD5 hash and hash.txt using the words in word list with a dictionary attack. It might take some time for the results to come in, so I'll skip the waiting part. And the results are in. The hash value appears to be subscribe. We've now reached the end of our video. Throughout this journey, we've covered many topics. I hope this information has helped you become more proficient in cybersecurity and use Linux more effectively. We must never forget the importance of ethics in this field. Becoming a cybersecurity expert is not just about technical skills, but also about having a strong ethical understanding. It's imperative for us to always act in accordance with laws and ethical guidelines. Also, we've seen how critical it is to do research and continuously learn in this field. As a cybersecurity expert, we must constantly research to stay up to date and follow new technologies. Don't be lazy, be curious, and keep improving yourself. If you have any questions or want to delve deeper into specific topics, please share them in the comments. Thank you for watching us. See you in the next video.